years ago, maybe about 60 years ago when I first started teaching, I started doing the regular thing, you know, teaching people that things like this, -1 times -1 is equal to +1, and things like, this is how you multiply fractions, kids. 2 times 2 over 3 times 1 over -5, that would be the same thing as 2 over -15. And then people would ask me about why, and I would say, because that's the way it is, look at the book. And this was the standard quote at the time. But I would go home and I would feel really bad. I would feel like a hypocrite, because I knew that there was a much better, much deeper, much more appropriate explanation for this, and I was not giving it to them. When I was your age and I was taking the class, nobody gave it to me, and so there's this perpetual tendency to treat students like insects and not even explain them what really should be explained, either because, I don't know, you presume they don't or can't understand it, or it's not worth learning, whatever. Point is that I felt like a hypocrite, because I knew there was a much better answer and they were not getting it. So that started a long time ago, and I wasn't gonna have it. So I had this this crazy idea. I thought that maybe I would set out one day and design the very best algebra class that anyone has ever designed. One that actually taught people, not just helped them memorize facts or a bunch of mumbo jumbo, but one that actually made sense from the beginning. I set out to design the Bugatti of algebra classes. That's what I thought. One day I'm going to design the Bugatti of algebra classes. And now, 60 years later, I still think that someday I'm going to design the Bugatti of algebra classes. Until then, well, we have this. So that was a crazy idea, designing an amazingly good algebra class that actually taught people a little bit deeper than just having people memorize, this is how you multiply negatives, this is how you multiply fractions. There was a much deeper explanation. And so that's what we set out to do, and today's our first day. We get our first dose of actual mathematics. Don't worry, it might feel a little bit different than other math classes, but you're in good hands. Alright, so let's get on with it. Let's get started. We're going to start off with some vocabulary. We're going to take it easy every day. We'll learn 2 or 3 new words, and that's it. We call it a day. Super easy. I think you're gonna love it. Many people have taken this class and they've gone on to do some amazing things. Some of them are math teachers, contenders for Teacher of the Year in the state of California. A lot of good things have happened here. A lot of people tell me they're adults, and throughout their whole life they've never really understood math. It never ever made sense until they take this class. Don't be afraid. It's going to be good. Trust me, I'm a doctor. I've done this before. Let's get on with it. Some vocabulary. In this class, one of the central ideas is the idea of mixing items. What we mean by mixing items is, well, you might have seen it in algebra, something like this. If I take 3 and I throw it in a bucket and I throw 5 in there and I mix it all together, and the mixing recipe is addition, well, you get 8. This idea is called mixing two things, and there's other ways of mixing them. You don't have to be addition. You could be multiplication, and you could take 3 in there and you take 5 in there and you get out 15. This idea of mixing is incredibly important. It's called a binary operation. The idea of taking two things, binary, and then using some predetermined recipe to combine them into one item. The idea is much bigger than just numbers, and is much bigger than just addition and multiplication. For example, you could mix colors. Think about that. If you take red and you pour it in there with yellow, and you pour it into the bucket, of course, and you mix them, this type of mixing of colors would probably give you something like a different color, orange. Really, the only limitation is your imagination. You can mix anything in the world. It's part of a big idea. Sometimes as you take more math classes, you'll be mixing matrices, functions, polynomials, bunch of things. For our class, we will focus on these two, and we'll give this mixing idea a fancy name. The fancy name for these mixing recipes is a binary operation. Binary operation, that's what we're going to call it. And there are some famous ones that we will deal in the class. The famous ones, of course, are addition, multiplication. These are the most famous ones, and there's also division and subtraction. These are lesser operations. They're not quite as they're famous, but I think we're going to get more mileage out of studying these two than those two. So we're going to focus a lot on these ones. Okay, we should summarize this. Maybe make a little box here. This is your first vocabulary word, a binary operation. It's a recipe for combining two items into one. And it's a big idea. It's not just limited to our class. You'll get mileage out of this idea for all the math classes that you take, and even non-math classes. It's a nice, powerful idea. Okay. So that's your first vocabulary word. Learn it, binary operation. Next, we want to take a look at the players, the things that we mix. As stated earlier, the idea is really big. I mean, I'll do something a little wacky here. You could throw in there, for example, a bicycle with some handlebars or whatever, and you could throw a chair here. Wait, that's not a chair. This is a chair. And if you throw them in there, mixing, maybe you get something like a wheelchair. And so the idea is really big. You could be as creative as you want. These things, the things you throw in there, and into the mix, that's it's called your domain for the operation. It's the things that the operation works on. Those are the players. And so we're going to try to separate them into buckets, and so we have more vocabulary so that we can learn these buckets of items. They go something like this. We call this section what we mix, the things that we're going to mix, or the players. Sometimes the things that we will be mixing will be variables. So for example, I could have x added to 3x squared. In this case, these things are called variables. These things are called terms. That will be down the road, and these are called polynomials. Okay. Another type of items that we will be mixing will be fractions, and I'll tell you more about that in just a second. This is our first day, so we're going to start off super easy. We're going to start off with just studying natural numbers. Now, let me pause here and say a couple things about natural numbers. These are numbers that you use when you would count. For example, when you would count your number of fingers in your hand. They go like this: 1, 2, 3, 4. Notice 0 is not there. Notice 4.5 is not there. Pi is not there. There's a bunch of numbers that are not here. These are just the most basic numbers that you can think about. And I don't have time to write all of them because there's too many of them. There's infinite many of them. There are more numbers here than there are atoms in the universe, so I'm not going to write them all. Sorry. Instead, what we usually do is you put a few dots, and that implies that you continue the pattern. And then you close it, and this says, hey, I've got a collection of things. This is a bucket. I'm describing the collection of all the natural numbers. We even have a symbol for these guys. This symbol is called, is a fancy N like this. That's called the natural numbers. Okay? And those are some of the things that we will be mixing now, especially being our first day, our first week. Natural numbers, right? Some vocabulary words. Other famous vocabulary words may be integers. You should get to know. Integers have all the natural numbers and then some. They also include this amazing number called 0 and some other numbers that have a little line next to them. You might have seen them before. They're called negatives, and they go on forever both ways, left and right. Now the Germans got to this one first, and in German integers it's Zahlen, so they got to it first with their famous letter to represent them, Z, a fancy Z with a double edge here, or bold Z. That's called the integers. Those are some of the things that we will be mixing. We will learn how to multiply them, add them, combine them. We're not just going to learn, we're going to really learn how to multiply. And why is it that when we multiply negative times a negative is a positive? Why is it negative times positive negative? But when you add them, sometimes it's not. It's a lot of things that you've been told all your life. But we're not just going to tell you. We're gonna do it right. Someday I'm gonna do the Bugatti of algebra classes. All right. Rational numbers, another famous one of the things that we will be doing. In your mind, whenever you see rational numbers in a math class, it's not the same as what it would mean in English. Rational usually means sensible in English, but in math it means something else. It just means, roughly speaking, it means fraction. Sort of like this. It will be the collection. This means a collection, a bucket of all fractions a over b. This means such that a and b have to be integers. They have to come from this world over here, from the world of integers, and b cannot be 0. This is a super fancy way of saying the collection of all fractions such that the top and the bottom are all both integers and b is not 0. That would be a rational number. So for example, something that's not a rational number, the square root of 3 over pi. Sure, it's a fraction, but these guys don't come from the world of integers, so it's disqualified. 5 over 0, that's a fraction, but it doesn't come from the b is 0, so that we wouldn't call that a rational number. What about 3 over 1? Yeah, well, let's see if it fits the bill. Is the top and the bottom, are they integers? And is the bottom 0? No. Okay, perfect. That guy's in there. This is a bona fide, legitimate fraction. A fancy name for them, rational numbers. We also have a fancy symbol for them. This fancy symbol is this fancy Q with a double side, or sometimes it's written as bold. It's hard to do bold here, so we just do this double edge. Alright, that's it. Those are your major players that we will be studying the first couple weeks. Add that to your vocabulary list. I think we can summarize it. Let's summarize it in a nice little box. Natural numbers, that's a fancy N. Integers, they contain all those, and 0. I forgot to put the 0 here. There it is, 0. Rational numbers, all fractions such that the top and the bottom are both integers and the bottom is not 0. Okay, there you go. Vocabulary. Let's see. So that's I think we learned 4 words today. We learned binary operation, natural numbers, that's those, integers, and rationals. I told you we're gonna have a super easy day, so we're almost ready to wrap it up. Before we do, why don't we do this? Why don't we learn 2 axioms? Now let me say a thing about a couple of things about axioms. Axioms are, roughly speaking, they're just the rules that we accept. You don't have to prove them, you just have to accept them. Why do you have to accept them? Well, so you could play the game. But really, you don't really have to accept them, because you, with your 3.5-pound brain, you could make up your own rules. Except we wouldn't call it algebra, maybe you have some other name for it. But if we're going to play the algebra game, we're going to set down some rules. And so we have a fancy name for the rules. Called axioms. The guy that made this super famous is Euclid. Amazing guy, changed the world forever. He wrote a 13 Elements, the most famous textbook ever, with absolutely 0 applications, and it changed the world forever. So, next time you ask, well, what is this good for? Hey, what are the applications? Don't tell me you want to see lawnmower problems. Joe mows the lawn in 5 hours. Jane mows the lawn in 2 hours. How long does it, the girl always mows it faster, by the way. How long does it take him to mow the lawn? This is the armpit of mathematics. Nobody has 2 lawnmowers in their house. Alright? No applications. I hate applications. They are the armpit of mathematics. Euclid apparently hated applications too, because he put 0 in his 13 books, volumes. The Elements, and it made it super famous. Anyways, don't get me started. What we want to do today is just learn a couple axioms. We're going to have a super easy day. 4 words that we learned and a couple axioms. So, the first one. Alright, our second axiom, times table. I think you already know it already. Based on the previous one, you probably already know what's happening. So the same deal as before. We assume that we have a table here. We have natural numbers, 1, 2, 3, 4, etc. 1, 2, 3, 4, etc. We have a binary operation. In this case, it's times. That's different than before. 1 times 1 is 1, 1 times 2 is 2, 3, 4, 2, 4, 6, 8, 3, 6, 3. I know you're asking, how is he getting that? I'm multiplying. 3 times 3 is 9. Use your calculator if you're lost in here. 3 times 4, that's 12, etc., etc. Dot, 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 dot. That's called the times table. This is what you learn in kindergarten or first grade or something like that. We will assume that all of us know this for the natural numbers. So here's how you would use it. You would use it. Suppose someone said, hey, what's 3 times 5? And you say, well, that's equal to 15. But why? Why is it? Oh, because of the times table. This says, Bugatti of algebra classes. This says, I know what I'm doing. This is, I got a 3.5-pound brain and I love it. This says, I'm putting swagger on my walk. Alright, I'm going to be the life of the party because I know what the hell I'm doing. That's what that says, alright? If you don't want to be the life of the party, if you don't want to have any followers on Instagram, leave that out. Just saying. Alright, another way, for example, 2 times 6. How much is 2 times 6? Well, that would be 12. Why? Because of the times table. Okay, that's why. Notice what it doesn't say. For example, it doesn't say how much is 0 times 3. We don't know. Why don't we know? Because 0 is not on the table. How much is a half times negative 3 over 7? We don't know. Why? Because fractions are not on the times table. How much is x squared times x to the third? We don't know. Why? Because the x's, the variables, are not on there. Only natural numbers are there. That's the times table. Alright, let's summarize it. I told you we're going to have a super easy day. Didn't I tell you? Let's clear the screen and let's summarize what we just learned. So multiply natural numbers, make a little table here. This is the symbol for it, almost the same as the other symbol, except instead of a plus, it's a times. Let's summarize the whole thing. So we learned a word, we learned binary operation, the recipe for combining two things. This is going to be crucial for our class, for all the classes, for your life. We learned famous sets, 3 famous sets, natural numbers, integers, and rational numbers. We learned the addition table axiom with its symbol, and we learned what it says and what it doesn't say. It says that we know how to add natural numbers. It doesn't say anything else. Okay? Just that we know how to add natural numbers. We also learned the times table, which says that we know how to multiply numbers. And it says nothing more, nothing less. We know how to multiply natural numbers. And this means something. Natural numbers, those are these guys over here. Again, I forgot that my 0 here. And that's the summary. That's our first day here. Super easy. We're going to do this every day for the first week or 2. Learn 2 or 3 axioms a day and just relax. We have to learn the rules so well. Otherwise everything is lost. This should have been done in 3rd and 4th grade, learning the rules. But no worries. I got your back.